presentation on our group's Capstone project and the key metrics we have gathered from the data we are using. Let's start by understanding what a photovoltaic system, or PV for short, is. PV systems use the sun's energy to make electricity. A PV system therefore eliminates or reduces the amount of electricity you purchase from your utility. The typical size of a residential PV system is 2 to 5 kilowatts. PVs have become increasingly popular over the last few years. As you can see from the geospatial plot of the PV installations in the state of Massachusetts over a period of 4 years from 2010 to 2014. The other important consumer product we will be looking at is the EV, or electric vehicle, which uses energy stored in its rechargeable batteries. These batteries can be recharged by common household electricity. Examples of EVs are Tesla Model S and the Chevrolet Volt. The Capstone objective is to create a data-driven predictive model of the impact of varying levels of PVs and the EVs. From the perspective of impact on utility distribution system operations, PVs and EVs represent the highest per instance impact of any new customer product since the introduction of air conditioners and clothes dryers. The Capstone data is from Pecan Street, which is a Texas-based organization that provides data derived from voluntary participation of households from Texas, Colorado, and California. We analyze hourly power consumption of over 1,300 households during peak and off-peak hours. Peak hours are defined by the Texas Power System as 8 hours to 22 hours on Monday through Saturday. All the remaining hours are considered off-peak. Other house characteristics included in the data set are location, building type, year of construction, total square footage, number of floors, presence of PV panels, and EVs. From our sample set of around 720 households, almost 69% live in single-family homes, followed by 25% living in apartments and 5% living in townhomes. 37% households have PVs, while only 13% have EVs. After our initial analysis on the types of houses and their adoption of solar panels or PVs and electric vehicles or EVs, we conducted further analysis on power consumption by Pecan Street houses. The box and whisker plot here displays the ratio of power consumption from grid during peak and off-peak hours subject to adoption of PV and EV. With the installation of PV, households have relatively lower peak off-peak electricity consumption ratio. Some of those households could even feed electricity back to the grid. However, the adoption of EV did not have significant impact on the ratio of peak off-peak electricity consumption. In comparing the average power consumption from the grid during peak hours, we observed that the presence of PVs significantly reduced the net grid consumption across all house types. In some instances, the average power consumption from the grid in peak hours was negative, indicating that the household was able to feed excess power back to the grid. Finally, we also have created an interactive dashboard to provide a comprehensive view of household in terms of their power consumption during peak and off-peak hours. For example, if we focus on the households living in single-family homes, we see that many have adopted to EVs and PVs. We are also to observe how this impacts the average power consumption. While households that occupy apartments do not appear adopted PVs or EVs.